Hello and welcome to part 4 of Dev Maths and Stats Refresher Course, Lecture 7. So when we move on to dependent probabilities, which we're normally dealing with, probability space diagram is a bit inconvenient or a bit awkward. Often better with a tree diagram, which I'm sure everybody will have seen before. So this is a tree diagram showing the situation above, and what happens is this is the starting point, this is the selection of the first country. And I could draw it with low income, middle income, high income, but because we are focused on low income, yes or no, I've done it like this. So this is a low income, this is not a low income. And then after that, this represents the second draw of a country. So after the first is low income, the chance of getting the second one low income, the chance of getting not low income. This means first low income, then first not low income, then low income. And this is both not so low income. So you can fill in the probabilities on here. So initially, it's 50-50 chance of low income, not low income. But then, if the first one is low income, then there are fewer low income ones left. So you've got less chance of getting, only a 1 in 3 chance of getting another low income. Whereas if the first one is not a low income, then there's more chance the second one will be low income because there are 2 out of 3 low income. So this clearly shows you how the probabilities in the second stage depend on what happened in the first stage. And then once you've got that, to get the probability of each branch, you just use that rule of multiplying the probability of low income and low income is probability of low income for the first one times probability that the second one is low income given the first one is low income. So if you've seen these kind of diagrams before at school and so on, then what this is adding in here is the idea that this is called the conditional probability, or the conditional probability. So for example, this one here you'd label it as probability second is low income, given that first is low income country. This is supposed to say equals the first probability the second is low income country, given that probability, given that the first is low income country is this number here. And this is just probability first is low income. So you multiply this times this, and you get the probability that they are both low income countries, according to the law of dependent probabilities. Okay. And then finally, you can use the OR rule. If you probability of ending up here or here, you just add up the branches at the end. So best thing to do is to apply this. So rather than just show you stuff which is pre-prepared, I'll do this by hand because this is what you have to do if you do the test. So what I suggest you do is do each part of this and then pause, and then you can watch and see if you're doing the same as I'm doing. So try to work ahead and do this for yourself if you can. So this should be a good refresher on when you've done this previously. So you select 2 students at random from this class. What's the probability the first one picked is studying impact evaluation? So at time of writing, we actually time of writing this year we have more economists. So we have at the moment we're expecting 7 development economists and only 4 at the moment in impact. So this problem would have been very different the last few years, where we've had more like in the teens in both and more impact. But this is like this, so that changes the probability slightly. So the first question is a really simple one, and I'll take this as an opportunity to write down the probability notation. The first one picked is studying impact evaluation. So I'm going to base all of this off a tree diagram. So I'll draw that first, then we can put the probabilities on. And I'm going to use notation like this. So let's put the impact period on top. Some years we get people that are doing neither course that just opt to do it because they want the extra maths. This year impact evaluation and economics are exhaustive, so we can do this. So this is the first one. I'm going to put a 1 here So that's the first person picked. So I1 means the first person impact, E1 means the first person is economics, and then this is the second round of selection. So I2, E2, and I2, E2. And then you can start filling in probabilities. We've got 7, so the first ones you pull out of a hat or randomly select from a computer, the chance of getting impact evaluation is 4 out of 7. So this must be 7. Good start. So out of 11 then. 7, 11. Okay, and then we get the dependent bit, because the chance the second one is impact evaluation, given that the first is impact evaluation, well, there would only be 3 remaining out of the 10. Whereas there'd be 7, all 7 development economists remaining out of the 10, so that would be the probability there. Here we still have the opposite situation. There's all 4 impactors are still there out of the 10, but we've lost one of the development economists, so it'd only be a 6 out of 10 here. So these are the conditional probabilities, conditional on what happened in the first round. And now we can actually remember what we're supposed to be doing in this question, which is finding what's the probability. The first one picked is studying impact evaluation. Okay, well that's pretty easy. So question 1 is just this. Just 4 out of 11. Okay, that's an easy enough one. 2. Probability here. What's the probability they're both taking the same course? Okay, that would be the probability of either I1, I2. Oh yes, I've got more notation here. I'll put or instead. E1 and E2. This is used as a shorthand for and, often in probability. Sometimes you have upside down for or, but maybe that would be too confusing. So I'm using that for and. So probability of I1 and I1 and I2 or E1 80. So in other words, what's the probability of being here or here? They're both doing the same course. So to get here, we can multiply along here. So you've got 12 out of, got it in black, 12 out of 110. The chance of coming down here is 42 out of 110. So that's multiplying, which is doing this AND rule. So the OR, because they are exclusive, you can't be both, you can just add them. So it's the probability of this plus this. Which is 12 over 110 plus 42 over 110. So it's going to be 44 over 110. It might even be 54 over 110. Which is 27 over 55. So this kind of figure. All right, question 3. We got probability that the second person picked is studying development economics. So the probability that E2, so that's here or here, is the probability of I1 E1. I won't write the AND, or E1 E2. I1 E2, sorry. probability of I1 and E2 or E2 and E1 and E2. So again, you can split them up like this. So you're looking at I1, E2, which is here. So we've got, it's going to be a 28 and E2, E2, 42. So we've got 28 plus 42. Oh no, so this time we've got 70. 110. So that's 35 over 55, and you can cancel it down. But 35 over 55, which would be 7 over 11. No, actually, it's obviously 7 over 11. Divided by 10. So that's 7 over 11. The chance the second one is picked is a development economist. They are not both studying impact evaluation. So, in other words, they are not both studying this one. So the two ways of doing this are you could work out. This is asking us what's the chance of I1 E1 or E1 I2 or E1 E2. So it's this plus this plus this. So 4. But a quicker way of doing it is going to be probability of not I1 and I2 the probability of not that, the quick way of doing it is to do 1 minus this probability. So it's 1 minus the probability of I1 and I2. So that's 1 minus 12 over 110, which is 98 over 110, and which is 49 over 55. So it's simpler to do 1 minus that. Okay, E. Second person is on the impact evaluation course if the first one is not. Well, we've got to 5. So that's probability that second one is impact evaluation. Now here's the one we're writing as dependent probability, given that the first one is not. In other words, given that the first one is E1. So probability second is I, given the first one is E, which you can just read off because it's just this probability here. That's exactly what this is. Probability that the second one is I, given that the first one was E, so it's just 4 over 10. Straight from there. 6. Final one. Probability that the first person is development economics if the second one is impact evaluation. So in other words, it's exactly the opposite of this. So the probability that the first person was E1, given that the second person is impact evaluation. In other words, you know you're here, or possibly here, one of those two. What's the chance that you actually came down here? The first one is economist. And what you need to use is the Bayes rule that lets you flip it round by doing this. So you can flip things around like this. So it's flip it round times the probability of the first one divided by the probability of the second there. Because if you multiply it out, they both give you the probability of both things happening, A and a B. So, answer this question. So it's the probability of, flip it around, given E1. So we've got that. That's the first part we had already. Times probability, times the probability of E1, just write like this. Divided by, oops, probability of I2. Which is getting a bit long here. You can see the symmetry in this, because multiply this I2 goes with this I2, this E1 goes with this E1, and they both give us they're both different ways of saying the same thing, which is the probability of having both I1 and E2. E1 and I2, sorry. So they just substitute all this stuff. So this is 4 out of 10 we've got already. Probability of I1 given E2, which is this. This is just the probability that the first one's E1, so that's 7/11. And then divide by, put a monster bracket. Probability of the second one is I2, so that could be here or here. So it's 411 times 310. That's the probability of I1 and I1. Or it could be E1 and I2, so E1 and I2. 7/11 times 4/10. And this should make intuitive sense because this 410 times 7/11 is the chance of coming to this place here. So if I call that A, B, C, D, these combinations of outcomes, this is the probability of C, and this is the probability of A, and this is the probability of C again. Because the initial problem is telling you, we know the second was I2, so you know you're either at A or C. What's the chance that the first one was E1, so what's the chance you're at C? So what is the chance you're at C if you know that you're either at A or C? So it's C over A plus C. So it kind of makes sense, that rule. And then you can multiply both the top and bottom of this by 110, because it's going to be 110 here, divided by 110, 110, so forget all that. So you're just going to have 28 divided by 12 plus 28, which is going to be 28 over 40, 30, 40, which is going to be 7/10. Okay. So the two things to notice are this method of how you do it, but also perhaps more importantly than that, it's just the basic fact that look how different these two things are. This one, like, incredibly easy, just read off there. This one you have to chug through a lot of calculation. So beware that they are different things. Chance of the second person being impacted, if the first one was development economics, is 4 out of 10. But the chance that the first person is development economics, if you know the second person was impact evaluation, is 7 out of 10. So different probabilities, different concepts, not to be confused. Okay, thanks very much. We'll go on to some further examples to do with probability distributions in the next, or random variables in the next section. But thanks for watching.